Hi, this is Margo. This is Sunday early evening, October the 3rd, 2021. I hope everyone is safe and doing as well as possible. I'm hanging in there, and we've made it through another week. This will be my weekly update that I'll be putting on YouTube, where I'll be going over methane for the week, sea ice, and I'm going to give an update on Palma and other climate things. So I'd like to welcome everyone to the show today. I do updates during the week that I put on my Subscribestar page. So if you'd like to join us over there, we'd love to have you. The link is in the description box below. So I'm going to start out with the NOAA methane data. Now remember, NOAA had been offline for a couple of weeks, especially the METOP2 satellite, but they came back online, but with little ribbons of data on the METOP2. But I'm counting it. That's what we've got. That's what they're presenting to us, and so I'm moving forward with that because that's what they're releasing for the data. So we'll just go with that. So we're starting out with the METOP1 satellite, which has been renamed the METOP-B satellite. This is for the 477/469 millibar reading for the 10th for the morning, and the mean or average was 1936 parts per billion. The high reading was 2454, and we still got pinks around the Antarctic, and the pink area is a range between 2000 and whatever the high reading here is for parts per billion. In the afternoon, the mean was 1936, the high reading was 2491. And this is the new way that the METOP2 satellite data is showing up, with these little ribbons of data, and it covers a lot of the Arctic and it covers a lot of the Antarctic. But considering how we've got such high methane readings in the Arctic, I'm thinking we're getting a lot of it here. So here we are for the METOP2, aka METOP-A satellite. In the morning, the mean or average was 1928 parts per billion, so that's high, and then the high reading was 2881. And then in the afternoon, the mean was 1917, so that went down. And look at this, we've got a high reading of 3299, so we have a spike there. We don't know where it is. It could be anywhere in the pink zone. So that's what we've got there. And here's the spreadsheet where I've been tracking all of this. So for the second, that data averages out to be 1929.25 parts per billion. That's showing an increase over the week before of 7.75 parts per billion. And so we can see our blue line going almost straight up here for this last week. And so since a year ago, we're up 27.75 parts per billion higher, and we're 72 parts per billion higher than when I started all this on March the 1st of 2019. Now, we probably haven't peaked out. Normally, methane peaks out sometime mid to late October in the season. Last year we had twin peaks one in September and one in October, and so I mean it's still, when we see an increase like this with the new reporting data, 7.75 in a week, you know, we're still in high methane. Now here it was last year. See, we peaked out on September the 25th at 1904.25, and then it did a little stair-stepping for a few weeks, went down and up and down, and then on the 23rd it peaked out at 1904.25, the 23rd of October. So that was last year. The year before that, we peaked out on October the 12th at 1885.75. So we're way above that. And that was so that was in 2019. So this is my third year to be doing methane. 2019, 2020, we looked at that, and then this is 2021. So we'll see where we end up. I mean, at this point it looks like it's going to be going up for a while. So I'll show you what happened this week. So here it was on my show last week for September the 25th for Saturday, and we were at 1921.5, and that had gone down. There was a daily decrease for the day of 4.25, and we'd gone down half a part per billion that week. So that was for Saturday. Then Sunday it went up 1.5. Monday it went up 2.25. Tuesday it went up another 1.75. Wednesday it went down 0.25. Thursday it went down 2.25. Friday it went back up 2 parts per billion, and then Saturday it went back up 2.75 parts per billion. So we're ending, that's the highest reading we've had so far this week. We're ending 7.75 parts per billion higher than where we started last week, and 27.75 parts per billion higher than a year ago. So a year ago, see, I started tracking this on a daily basis. Let's see. So a year ago, October the 3rd or 2nd, October the 2nd was I lost it. Sorry. October the 2nd was 1901.5. That's where we were last year. And 1929. So we're in no man's land. We're again higher than we've recorded so far. So we're setting records all the way around. So I'm wondering, with the methane zipping up like this, if we're going to start seeing a some higher temperatures globally as a result, because that's what they've been saying would happen when we started seeing super high methane readings, that the temperatures, but every month it's hotter than it was the year before, so we're just going to have to keep an eye on it. So now we'll look at the CAMS data. I have this is from Copernicus Atmosphere Monitoring Service out of the EU. This is for Saturday, October 2nd, Arctic view and surface level. There's our color ledger. So the data is for Saturday, and the forecast period is Sunday through Wednesday. Here's Greenland, here's Canada on the left, and Alaska. All this area on the right is Russia, and then this is northwestern Russia, Finland, Sweden, and Norway. And we've been seeing some really high readings. See here at the beginning here in this Russia-Finland area, and it's been releasing out through the Barents Sea. This has been going on for a couple of weeks now. This really high release. I don't know what that's from, but see, we've got something going on the coast of Norway there. And we've got high readings throughout Russia still. This could be from permafrost thawing. It, could be from, if it was raining, if it's a swampy area, I don't know. I'm wondering how much of this has to do with radioactivity from left over from all the nuclear testing around Novaya Zemlya during the Cold War era, because I know that the Kara Sea is very radioactive. I'm wondering how much of that may be spread out or got caught up in the wind and went over the Barents Sea onto Russia. I just don't know. I mean, these are just thoughts I've had. We're still seeing it coming up by Komsomolets. That's not stopping. And I have my theories about that, but they can't be proven because no one's investigating that area. Who could? And I don't know who could. I don't know if this is part of Russia top secret protected territory or what. But if any climate scientists could investigate that area, I think that would be of high interest to see what the source of that continuous billowing of methane near Komsomolets is, because that's got to be adding a lot of methane into the atmosphere there. I would want to know, because there's nothing there. There's no oil rigs, there's no cow farms, there's nothing, there's no civilization, nothing there that would be causing this to come up through the ocean. It's got to be coming up from the seafloor. It's something that's on the seafloor, either methane vent that's opened up, or a crack, or sunken nuclear submarine that's had problems. I don't know. Those are my thoughts. And then we've got Canada. Look at what's going on. This huge area in Canada. just looks awful there. What's going on there? This is the Hudson Bay, so it's this whole area below the Hudson Bay that's kind of like a big blob there. We've got our little problem spot in the North Atlantic still right there. Now we'll go to the North Pole view. Here we can see most of the northern hemisphere. Now we can see UK, Ireland. Here's Europe. See, that's, well, there's Germany, and down into Italy. That's filling up. Here's the Persian Gulf. That's filling back up. See how it's spilling over very high readings around into Saudi Arabia, also into Iran over on the other side. Here's India. See, that's starting to fill up down to the southern tip. Here's China. Korea. Here's Japan. See this arm, see this wave. It does this from Japan every few days. I don't know, I haven't tracked, but every few days this big arm releases and moves out. And then here, look at all these hot spots in the US. Texas looks awful. All this area around the Gulf Coast. See, look at that. California is not looking good either. Florida. Now, someone left a comment about Florida. What's going on with Florida? Florida's kind of a hot spot for methane because it's very densely populated, plus it's very humid, and there are a lot of swampy areas decomposing matter, and all that mixed together will give you high methane. It's very humid, very swampy. It's just I've always seen high methane down there. And look at this east coast of the US. Anywhere you have dense population, that's kind of a big methane maker. Now we'll go to the Antarctic. I've been showing this every week. So here's north, south, east, and west. This is the Western Peninsula. This is South America, coming down with that point there. See the light blue, that's methane coming up. This is the Ross Seas down here. Having a brain fart. This is the Larsen B, where the Larsen B ice shelf used to be. It collapsed a few years ago. There's methane coming up there. Here's some more methane on this Western Peninsula. We've got a new area popping up. This is a little island in the Weddell Sea. It's kind of frozen in the ice there, but we've got a new hot spot there popping up on the north end of that island. See that? And then all along this Brunt ice sheet, it's coming up along that coastline. We've got it's sporadically popping up on this north coast. See, right there on that tippy point. Let's see what else. Sometimes we see it coming up here at the Amory ice sheet. I'm not seeing anything today. Sometimes we see it coming up on the southern edge next to the Ross ice sheet. I'm not seeing that today. Now we'll go to the global view. Now this light blue color, this has been the predominant color in the southern hemisphere for most of the summer, because as methane gets higher worldwide, it's reflected through these colors. And with the color chart, that's 1820 parts per billion. This is at surface level. This dark blue is 1800, and when methane starts going down, we'll see more of these dark blues creeping in the southern hemisphere, kind of taking over. So we have, like I said, wherever it's densely populated, we've got high methane. So China, India, anywhere also there's a lot of oil production. Here in the Persian Gulf, it's oil all around there. Also, here we have in Africa, Central Africa, where there are fires. They have fires. They burn. The farmers burn kind of all the time to burn off the old and let new growth come in. So that's or where it's hot and humid, like here in South America. See up here in Colombia, here in Brazil, Central America, hot and humid. Also where you have volcanic activity, a lot of times you'll have methane along with sulfur dioxide. So there's that. Methane. Yeah, methane and sulfur dioxide. So now we'll look at 500 HPA. This is almost equivalent to the level that we're tracking in NOAA. It's about halfway up in the atmosphere. And see the red spreading out. See how high it's like this wave has moved out over Alaska and Canada there. And see how high it is over Russia. And we've got a darker area here over the Pacific Ocean. This has come off of China and is moving out. We've got red further south too. Whenever you see the reds creeping down, that's a sign of higher methane too. And now we'll look at total column. So here it's highest here in China, in southern China and into Asia, northern India, and see we've got higher readings all around this Persian Gulf area too. We've been seeing, just this week, we've been seeing some reds pop up here in the U.S. or off the coast, and so we're seeing higher readings in places that we normally don't see them. Also, here in Eastern Europe, we've been seeing like the reds in total column this week too. So I want to go ahead and go through the rest of my CAMS images here. This is sulfur dioxide today. All this high reading and coming across the Atlantic. This is all from the La Palma volcanoes that are going off on the La Palma is the island. There's Cumbre Vieja and La Palma volcano. Those are the two volcanoes there that are erupting and the lava flowing, and it's a very serious situation. It's still going strong. The lava is flowing into the ocean now, and it's not stopping. And so now we're seeing high levels of sulfur dioxide in the atmosphere, and it's being caught up in the jet stream. And see, it's come across the Atlantic. Today it's coming almost down to South America. It's hitting the Caribbean islands there. It's also streaming out across northern Africa and all across. It had gone up north earlier this week, and it had hit Norway, and so it's affecting a lot of the world. We've got Kilauea going off in Hawaii, and this is all this sulfur dioxide is from that. We have another volcano going off here in the Philippines, and we've got sulfur dioxide from that, high reading there. This is at 500 HPA, and see here at Hawaii, see when it zips up into the atmosphere really fast, we see dense readings, high readings halfway up in the atmosphere. You can also see these waves. That's the shock waves around with the force that it's coming up. And so here it's drifted a little bit away from La Palma, but still seeing quite a bit at 500 HPA. Also here at the Philippines, it zipped up to 500 HPA. This is the ozone hole over the Antarctic today. See this white spot? This is below the black area. So this is below 100 Dobson units. It showed up yesterday on CAMS. So this is 2 days in a row that we're seeing, see that white area. Now all the area inside this black line is in the danger zone, and so we've got a huge area over the Antarctic that's is just all in the danger zone. And here's the black. That's 100 to 125 Dobson units, and so this white is below that. This is the first time I've seen it this low or this thin this year. And the sun is up. I mean, it's not up full force, but when we look at NASA Worldview, we'll be able to see all of the continent today. And here's the Arctic ozone, and we had a hole open up in the Barents Sea here this week for a couple of days, and it was in the danger zone. It was down into the purplish blue, and it kind of hung around in the Barents Sea, and it was about 2 days, I think, and now it's in the aqua, so it's still quite thin. Anything below the solid yellow is considered lower than normal. So see, even the yellow green, that's below 300 Dobson units. And here's the global view with ozone, and it's very sad. We're losing the ozone layer, and see all the green here over the US and Canada, here down into blue-green and over the Atlantic, and see the green all around the mid-latitudes. If you go back and look at my videos even a year ago, it looked a lot better than this. We had a lot more yellows. And the wildfires will eat it up. Sulfur dioxide will eat it up. Also methane will eat it. Radioactive will eat it. Also, nuclear reactors affect the ozone layer. There's when it goes up into the atmosphere, with the nuclear reactors, it keeps the ozone molecule from creating up in the atmosphere. So nuclear is not a good option. I know they're saying, oh, all this green energy and everything, but going nuclear, it's not a good option. That's all of those. Now we'll move on to our sea ice part. We're going to start with, this is sea ice and snow cover. These are images that I download from Climate Reanalyzer every day. This is for today. Here, here's our extent, and we can see where it had collapsed in the Beaufort Sea. That's filling back in a little bit now. That's the main part, and a little bit of extent coming back. But it's not really getting that much thicker. We also have a little wisp. Well, we can blow this up. We have a little wisp that's come back here on this east edge of Greenland, and it's coming back in these tributaries in the Canadian archipelago. But we've got rain. It's raining. I don't know if this is, I'm assuming it's not normal to have rain this far north, but you'll see today we've got rain. We've got rain at Novaya Zemlya today, and we've got rain up in this archipelago today. I guess that goes along with the warming that we've got. You know, we'll have rain later in the season, Okay, so let's go through and see what it did this week. Here we were last Sunday when I did my show, and see how this Beaufort Sea had collapsed down, and see the darker color. So it wasn't concentrated. There was actually a big hole there. So here was Sunday, Monday. Now this is a different view. This is the Russia view, because the model wasn't right for the Atlantic view for that day. Here it is for Tuesday. So see, it's starting to not be so dark here. It's starting to fill in there. Here's Wednesday, Thursday, Friday, and they didn't update it yesterday, so we've got I didn't get yesterday, and here it is today. So we're seeing the edges kind of filling in. It's not a huge refreeze yet. It's too early in the season for that. Now I'll show you. We'll go through the Navy models. U.S. Navy. This is sea ice thickness for the Arctic for today. And the dark purple is about 1 meter thick. And we're still seeing most of, well, here's quadrant 1 and quadrant 2. It's still mainly in the light lavender. We got a little bit of darker purple coming in around the North Pole. A little bit of blue. We still have a little nub of aqua ice here in the North Kara Sea, or I guess this is the North Barents Sea. Just anyway, this is just next to Severnae Zemlya. This had been up here next to Severnae Zemlya and had moved off, and so that's what's left of that. Now we've got a little bit of refreeze, it looks like, here in the North Kara Sea, and here on this west side of Severnae Zemlya as well. We've got, see the whitish, this is just like barely refreezing. If we look at NASA Worldview, this will be just a little filmy, like a little film, and see the film is coming back around the coastlines there. And here in the Beaufort Sea, see that's filling back in, and see the extent is coming back to, this is Alaska and Canada here, almost to the coastline there, it looks like. And in these tributaries, see, now we've got a little bit more purple coming in here. And in this upper Baffin Bay, we've got a little refreeze going on there. And so this is what we have left for thicker sea ice now. Sea ice of any consequence just above Canada here in quadrant 4, and just a little tiny bit here in quadrant 3. It doesn't look like it's really changing that much. It's just kind of holding right there. I don't see it thickening yet. Now last year, at the end of the melt season, what we had left was an area, you know, kind of more in a half moon shape, like that, and we watched it move down, migrate down with the ice drift through the winter. We used the models. We used the Navy model and we looked at the layers on NASA Worldview and watched that ice drift and settle down here into the Beaufort Sea. And so these little aqua nubs, that's what's left of that thickest sea ice. So now I don't know what this is going to do. We'll be watching this over the winter time and see what happens. We've got a little bit thicker ice coming in around northern Greenland here. Let's see. Now there's a space where it's thinner and then it gets thicker just above that. Here in the Lincoln Sea it's still pretty thin. Here's the 30-day animation. This one is updated to the data goes back 3 weeks and the forecast goes out a week from now to the 10th. So we'll zoom in and see what's going on here. See what they're showing. So this week I see the refreeze coming in around Severny Zemlya, and we see this eastern edge grow out, and this northern edge. What's happening here? Not that much on the northern edge. What's happening on this western side? A little bit of regrowth there. And here in the Beaufort Sea, just kind of settling in. Now let's look at just north of Greenland. See the hole we had, that's filled up now. Just north of Greenland. Let's watch this area now. So this is kind of spreading down to the west here, looks like. So I'm going to stop it and we'll look at it for the week. Okay, here we are at the end of the forecast period. So I'll show you. See? 10th. I'm really interested in that thicker ice. So let's go back. Here it is today, and see, it's pulled away from the coastline here, Canada, and there's hardly any bright aqua. The bright aqua is about 2 meters thick, and then the dark aqua is lower than that. So let's see, I think that's right. Yeah, see, bright aqua 2 meters. So let's click through and see what happens. Oh, it's sliding. You see it sliding down? See, this is lengthening and sliding down. Watch. So there we are at the end. So it's not anchored in. It's trying to anchor in, but it's not anchored in on Ellesmere. This is still quite thin around Ellesmere. So unless it anchors in, it'll just slide on down. So we'll see what happens if we get like a thicker refreeze this year like we did last year. I don't know. We're just in no man's land, and I don't know, what kind of experiments they're running up there to help the ice. I know they're running experiments, and you hear about them like after they're done. They're not talking about them while they're doing them. It's 6 months later or a year later they'll say, oh, we did this experiment for all these different months in this certain remote area, and here's what happened. So we don't know. That's that. Here's the Beaufort Sea ice thickness. This is hold on. Okay, they haven't updated this since October the 1st. So this is for October the 1st. And see the white areas, this is where it's pulled away from the coastline of these little islands here. This is Canada here on the right. Here's Alaska at the bottom. And it's just wispy ice refreezing there. I don't see a lot of thickening happening yet. We'll see it as time goes on, hopefully. And here's the so again, this was updated on the 1st, so the forecast goes out to the 8th, which is Friday. And it's moving. It looks like it's shifting down, just like what we saw last year, because that's the way the ice drift goes. That's the general direction of things. So there's that. Here's the Antarctic today. Sea ice thickness. And the extent has taken a nosedive. I think we've reached maximum for their summer, but I couldn't find any report on the internet about it. No one's saying. But it took a nosedive, and see, we've got a hole opening up here in the southern part, another hole here, and along the coastlines there's a lot of open water, see, or quite thin, and here even at the Weddell Sea, and here by Pine Island Glacier and Thwaites Glacier. So that's not good. Here's the 30-day animation. This so the forecast goes out to next Saturday, the 9th. So we'll see what happens here. So it looks like it's still thickening some, even though the sun is coming up. So there's that. That's all of those. Now we'll move on. Let's go. This is Sea Ice Index National Snow and Ice Data Center. This is for today for the Arctic. This is sea ice yesterday, I'm sorry. They're a day behind on reporting. Or they report the day after. So here's the concentration. See all the blues. What we want is the solid white. That's showing is more concentrated, meaning there's not a lot of open water, and it's thicker and healthier. Not that we have any really healthy ice up there. They're also showing regrowth here in the Gulf of Ob that I'm not seeing on my other models yet. Here's the sea ice extent for today or yesterday. Now the blue line is this year, and we see it is regrowing, and it's going parallel to our dotted line for 2012. And so according to all of the experts, we reached minimum extent on September the 16th, and now there's a little bit of regrowth happening. And this is the average line up here. We're still way below average. And remember, it's not healthy ice. It's quite thin and slushy, and anyway, it is what it is. Here's the Antarctic for yesterday. Here's concentration. See all the blues. Here's our extent chart for the Antarctic. And the blue line is this year. Now, see, it had started refreezing early in the season, and now, see, it took a nosedive. It looks like back in the end of August, first part of September. This gray-green line is last year, so we're below where we were. We're way below where we were this time last year. And the gray line is average, so we're below average too. And it looks like we did not reach the maximum of last year. It looks like we started going down before we reached that little peak up here. So when all's said and done, they're going to find that this year was not that great, especially with the nosedive like that. So there's that. Now we'll go through Climate Reanalyzer. This is 2-meter maximum temperatures for today. See all the greens. That's above freezing in the Arctic. This is air temperature. And here's 2-meter temperature anomaly. See all the browns. So this is warmer than normal, and all of a sudden now we've got the Arctic up 2.4 C higher than normal, and during most of the summer it was a lot lower. The anomaly was a lot lower than that. So somehow they kept it a lot cooler up here this summer. And I think it was probably manipulated like that. I can't prove it, but that's just my instinct. Here we've got reddish brown and reddish brown here in Greenland and Canada, and coming down through Canada and into the US. Lots of browns there. That's warmer than normal. The blues are colder than normal. And then see all this red in the Antarctic. And it's not surprising, considering the ozone hole lets through radiation that will heat things up too. So worldwide we're up 0.4 C higher than normal. Northern hemisphere is up 0.9 C. The Arctic is 2.4 C higher than normal. Tropics are up 0.4 C. Southern hemisphere is down 0.1 C. The Antarctic is down 0.7 C. So that's warmed up a lot. Here's precipitation and clouds, and see all this rain coming up. See, it's raining by Novaya Zemlya, the green, and it's raining here east of Greenland, and it's also raining right up here next to the Baffin Bay. See, in that little tributary, and in northern Canada here. See the rain? So it's also raining over Kamchatka, Russia, and so that's, you know, these are northern territories where we don't normally see rain like this, and the sun's going down, so it's supposed to be getting cold up there. Or colder. See the rain at Norway and Sweden there. Here's the jet pieces. There is no stream anymore. It broke earlier this year, and it's not going to be put back together. See the loopy? That's the breakdown of the climate when you see it like that. It's very sad. See that? This is what's causing all the different chaotic weather. We saw sea ice and snow cover. Here's sea surface temperature anomaly. So here in the Arctic, see all the browns. And we've got reds around Svalbard. It was raining at Svalbard this week. And so we've got the browns around Greenland, Hudson Bay. See, it's red and brown there. And see brown here along the Alaska coastline. So wherever you see those higher temperatures, it's going to be really hard to get any kind of refreeze going. And once it goes dark, we'll keep seeing these higher than normal temperatures, because it takes a long time for the temperatures to shift in the water. Look at this, all these reds. We're also seeing reddish and reds here between Japan and Russia there, and up here in the Okhotsk Sea. Mediterranean, see all the browns, reds and browns. Worldwide, we're up 0.5 C, higher than normal. Northern Hemisphere is up 0.7 C. The North Atlantic is up 0.9 C. Equatorial Pacific is up 0.1 C. Southern Hemisphere is up 0.3 C. And the North Pacific is up 0.6 C, higher than normal. Now we'll move on to NASA Worldview. So here's where the sun's going down, and so the areas that we can't see, where it's dark, and so we can turn on this layer, sea ice concentration, and it gives us an idea of what's going on. And we'll turn off the clouds. Here we are. And so we've got some refreeze going on this east side. And here's Severnae Zemlya. See the north. And we're not really seeing very much solid white. So the concentration is not that great. See the pinkish. Now the thickest sea ice is right up here and along this Canadian coastline, coming up here like that. And we're seeing it's changing. See the reds? That means it's not concentrated, means being pulled apart. Could be melting. I don't know. We've got a hole up here. See the green? That's a hole. And see a little bit of refreeze back up to the Russia coastline there. Here's one little dot in the Gulf of Ob. So let's go back to last Sunday. Oh, what am I doing? And we'll go to the 26th. And we'll see how it's changed this week. Here we were last week. So here's Monday, Tuesday, Wednesday. Now you can see this edge on the right bowing out, so that's a little bit of refreeze, and see it creeping out around this northern edge too. Here's the 30th, and here's the 1st. That was see a big jump there on the 1st, 2nd, and here we are today. So we'll turn the clouds back on. Turn off that layer, and we'll look at the satellite view. So we've got clouds. Got a lot of clouds here. Here's this little bit of refreeze happening on this northeast edge of Greenland. Here's the nearest strait, and see, this is cloud covered. Hard to tell much there. This is Ellesmere Island. See, that's already going into the dark. This northern edge of Greenland is already in the dark. Here's the sea ice. What we can see. See the wispy, that's the refreeze there. See that? Let's go this way. Let's see, that's open water. Looking through a cloud there. This is, see there? This is where it's pulled away from the coastline. And the sun is at an angle, and that's why we're seeing the blues and kind of strange colors. That's how it shows up. See the open water. The leads are still open. See the pieces of ice. So here's Alaska on the left. Here's the Beaufort Sea. Here's sea ice. See? And here's where it's a little bit thinner. We're looking through clouds here, but see the white pieces, that's ice. So it's, this is thin ice, but we're looking through clouds too. So this is the light purple from the Navy, what we see on the Navy. See a lot of open water there. See? Here's Alaska. I was too soon to say Alaska. Here's Barrow. I think that's Barrow. Sorry, I'm so disoriented today. Here's Barrow. There we go. These are clouds. So, see the cut and paste. These are different views from the satellite that come in at different times. See how different the clouds are? Just totally different. So here's Russia. Let's see, that's the Bering Strait there. These are clouds. Now, see that? That's the little refreeze. That's the wispy ice. That's the whitish part that we see on the Navy model. See? So here's Siberia. Here's the East Siberian Islands. Here is the Laptev Sea. Here's Taimyr Peninsula. Here's Severnaya Zemlya. This is Komsomolets, this little island here. So it's right around here that we've been seeing the methane billowing up. And if we go back yesterday, this is the Vovolov ice cap. See the ice is still pouring into the ocean. This is flowing from the ice cap into the ocean there. That's a good view. See, here's wispy sea ice there. Let's see, there's the sea ice. See, and then we're into clouds. Go back to today. And here's Novaya Zemlya, and we saw the rain on the west side here. See, there's the system. This is Murmansk. This is Russia, the Kola Peninsula here. So this is where we're seeing that the methane. We've been seeing the huge dark methane coming up from this area for weeks now, or a couple of weeks, from Norway over to this area, and it's been coming out here into the Barents Sea. And that's what we've got. Let's see. Let's go back to yesterday. See if we can see the ice a little better. Here we go. Let's see. See the cracks there. So we'll go back to today. Now we'll go to the Antarctic. So here we are. See, no black dot anymore. The sun is coming up. And it'll start warming up down here. So this is the Weddell ice sheet here. This is the island. This is a little landmass here. We saw the methane coming up just north of that. So right in here, this area. We saw that on CAMS. Let's go back to yesterday. Can't see anything. Here's the ice sheet. So there are cracks in the ice there. Let's see. See there. Here's the brunt ice sheet. Look at all this open water around there. And this is that, I think this is the piece that had broken off and it made its way down right there. See, a lot of areas where, especially up by the coastlines, it never really refroze, or it was very thin. So those areas are kind of part really fast. Here's this northern side. Here's the eastern side. Let's go back to today. Okay, here's the Amory ice sheet. Now we've got a cloud over that area today. Look at this open water. See? Then down here, this is the Totten Glacier. Here we've got clouds over that. But look at all of this open water already. See? This is melting fast. See? So it's already melted up to the coastline there. Then this is the Ross Sea here. This is the Ross Ice Shelf right there. We've got open water, see, right there around the ice shelf. Here's the Ross Island. We've got open water here, see. Got open water here. See? This is another area where we've seen methane coming up. Open water. Then up here, got clouds today. This is the Thwaites Glacier. And right up here is the Pine Island Glacier. Let's go back. See what we can see. Here we go. Here we were on the 30th. This is a good view. Here's Pine Island. And this is the sea ice. But look at this open water. It didn't refreeze further out. Right there. I mean, it did further down, but look at all this open water where it didn't freeze. And then this is the Thwaites Glacier, and we've got lots of open water there. Let's see. So that could melt really fast. And let's see all this open water around the peninsula. Let's come back. Here we are today. And let's see. This is the Western Peninsula. There's the tippy point. Right in here is the Larsen B ice shelf. This is an area we're seeing methane coming up right in here. See, that's ice. But there's cracks, see? It's coming up there. And here's the edge of the sea ice. So that's what we've got on our ice situation. Now, I'll just briefly go over La Palma. Let's refresh. So, here's their update, their big update for today. Here's a picture of the lava spewing up fountains. It says La Palma volcano eruption update. Eruption continues with vigorous lava fountaining and voluminous lava flows. The eruption continues at impressive intensity. I think I'm going to try the clean view. Nope, it's not on there. Can't do that. So we'll have to see the ads. The lava output rate remains very high and volcanic tremor is stable at high levels. The new lava flow from the separated vents just below the northwestern base of the erupting cone slowly make their way through so far untouched land north of the existing flow field, destroying additional buildings and other infrastructure so far spared. The flow forms an impressive channel of approximately 50 meters width, and there is no explosive activity at its vent. At the cone itself, approximately 8 vents in total are active, producing several lava flows, some of which seem to go directly into lava tubes, others overlapping older flows or feeding more or less stable lava channels. Some of the lava still finds its way to the sea entry, which is growing slowly. The upper vents produce tall, pulsating lava fountains with moderate ash plumes. When observed yesterday evening, the lower vent on the northwest flank of the cone, which had been a site of near constant low liquid fountaining, gradually ceased to produce fountains, but it seems that the energy then went to the northwest summit vent, which started an impressive show of violent near vertical fountaining reaching 300 to 500 meters height. So there's a video of that. A total of approximately 50 million cubic meters of lava have been emplaced so far, much more than originally estimated the eruption would be able to produce. This likely has to do with the continued earthquake activity that could suggest magma supply from a deeper source. The quake activity is quite intense. During the past 48 hours, the Monitoring Institute recorded 22 quakes of magnitudes 3 to 3.6. Most of them felt, and 45 quakes between magnitudes from 2 to 2.9. There are many more smaller quakes, but due to the strong tremor signal of the eruption acting as high background noise, they cannot be detected in the data. The earthquakes are currently located mostly at 10 to 15 kilometer depth beneath the southern part of the island, in a similar region as the earthquakes in the beginning of the seismic swarm that preceded the eruption. This is the area between the upper mantle and crust of the island, where magma from the deeper source intrudes into the volcanic edifice. There is no clear trend visible in the location of the quakes. They seem to remain stationary in this area, which might be explained that the new intrusions that likely occur there are able to use the existing pathways of magma through the island edifice. If there is a continuous supply from the mantle source, the eruption could last for much longer than expected, but this is speculation. So that's their latest update. This is from Volcano Discovery, and I've been posting their updates as public posts on my Subscribestar page. Now, what's interesting, if you go to Zoom Earth, now it's nighttime there right now, but when you zoom in and you turn on the fires, it shows the heat. This is the lava where it's flowed on the island where it is right now and where it's flowing, and this is where it's gone into the ocean. It's way out into the ocean there. So it's a huge amount of the island where the lava is flowing, and so when it hit the sea, and it's still going into the sea, it's creating toxic gas, toxic fumes from the lava hitting the sea there. Now, I saw something interesting. If we go over to this other island, Santa Cruz de Tenerife, this has a hot spot, and it's got heat, and when you zoom in, it looks to me like this is could be in a crater of a volcano. I don't know, but it looks like there are buildings around there. I don't know if this is a fire or if this is volcanic. I don't know. If anyone has any idea on this, that would be helpful. Just leave it in the comments below. Look at that. There are buildings right there. So whatever it is, it's taking over a large area. It's a heat like when there are wildfires or lava, or it's showing heat there. And I didn't see that on any of the other islands, but that kind of perked me up. So there's that, and we'll just briefly go over earthquakes from this week. Well, today we've got 206 right now worldwide. So the pressure has been released from a lot of activity going on. There was a 7.3 near Fiji, or near Vanuatu yesterday. Here's a 5.1 Kermadec Islands. But if we turn on all magnitudes for the last 7 days, we can see what happened during the week. Let's see, here was an Arctic earthquake. Here was 6.1 at Nanao, Japan. This was in the ocean, just between Japan and North Korea. That came in on September 29th. Here's another big one. Here was the 7.3 Vanuatu region. Again, it came in the ocean, so probably no damage done. But look at all this activity. Here in Iran, on the coast of the Persian Gulf, 5.2 and a 4.6. Near Bandar Geneva, Iran. Crete got hit big time. I didn't follow up to see what kind of damage there was, but look at all of these 14 earthquakes this week on Greece, and 6.0 that was on land, so there had to have been damage there, and then the rest were in the 4s range. Here's a 5.3 also. And we got Turkey. What was that? 4.2. We've got a small one today here in northern Italy, a 2.5 at Salandro, Italy. See, USGS will report that 2.5, but they're not reporting anything on La Palma, nothing. And can see the activity on this in the Atlantic. We've still had a little activity in the South Atlantic at the South Sandwich Islands. We've had activity here in South America. Here was a 5.9 in Brazil, near Tarauaca, and a 5.3 San Martin, Argentina. And then Hawaii. Look at this. 360 in Hawaii this week. And this was swarming. This is at Kilauea, before Kilauea started going off. This was swarming there, and Pahala too. 354 right there. Alaska, see, along the Aleutian Islands. Then, see, look at all of this California. We had movement on the Juan de Fuca plate. We've got a couple of 3s, 3.0 and 3.4. And we had swarming at Yellowstone this week. Look up here in this northwest edge. 137 here this week. We had 4.0 at Stanley, Idaho. That's a larger one. See the movement on this Cascadia zone region. Look at all of this California. And see, this line is where the San Andreas fault line continues. It turns into the Imperial fault line when it comes into Mexico here. So here was a 4.4 in the Gulf of California and a 4.4 further south, or at the top of the Cocos Plate, and then 4.0, 4.9. These are all in the ocean. There was, what's this? 4.2, El Puerto, Dominican Republic. We had South Carolina had some activity this week. 2.8 Somerville, 2.0 Somerville, and then a 3.3 just south of there. All in the same day, in fact. These were on the 27th. Just northwest of Charleston. We had activity in the central Arkansas. We normally don't see this. Near Enola at 2.3, 1.9, and 1.9. That's north of Little Rock. West Texas had 46 this week, including, looks like a couple at Midland, 2.9, but 4.1, I think that was the largest, near Mentone. Look at all of that. Most of them were out there at West Texas. And these are areas high in methane. Here in Midland, these are massive oil drilling facilities. Fracking, oil drilling, same with Oklahoma. So, there you have it. I'm amazed we're still here, frankly. It just amazes me every week when we make it through another week. That's my report for this week. And we'll finish up. I like to bring our focus back to spiritual, because when we talk about the end and extinction of all life, especially on the planet, how can you not talk about spiritual things? Because death is a spiritual thing. And so I'm reading out of the Bible. I'm starting back in the Gospels now. I finished up the rest of the New Testament yesterday. I've already done Revelation, and that's recorded on my website. So we started, we're going to do Matthew, Mark, and John, and that will finish up the New Testament. I've done Luke, but I decided to do all of the Gospels because this is the life of Jesus, and with this being in the end times, it's all about Jesus coming back, Jesus returning, and everything that happens in Revelation. And so I think the more we learn about him and his life and his teachings, the better prepared we will be for those times. So we're reading out of Matthew tonight. Matthew chapter 2. Now when Jesus was born in Bethlehem of Judea, in the days of Herod the king, behold, there came wise men from the east to Jerusalem, saying, Where is he that is born King of the Jews? For we have seen his star in the east, and are come to worship him. When Herod the king had heard these things, he was troubled, and all Jerusalem with him. And when he had gathered all the chief priests and scribes of the people together, he demanded of them where Christ should be born. And they said unto him, In Bethlehem of Judea. For thus it is written by the prophet, And thou, Bethlehem, in the land of Judah, art not the least among the princes of Judah, for out of thee shall come a governor that shall rule my people Israel. Then Herod, when he had privily called the wise men, inquired of them diligently what time the star appeared. And he sent them to Bethlehem, and said, Go, and search diligently for the young child, and when ye have found him, bring me word again, that I may come and worship him also. When they had heard the king, they departed, and lo, the star, which they saw in the east, went before them, till it came and stood over where the young child was. When they saw the star, they rejoiced with exceeding great joy. And when they were come into the house, they saw the young child with Mary his mother, and fell down and worshipped him. And when they had opened their treasures, they presented unto him gifts, gold and frankincense and myrrh. And being warned of God in a dream that they should not return to Herod, they departed into their own country another way. And when they were departed, behold, the angel of the Lord appeareth to Joseph in a dream, saying, Arise, and take the young child and his mother, and flee into Egypt, and be thou there until I bring thee word, for Herod will seek the young child to destroy him. When he arose, he took the young child and his mother by night, and departed into Egypt, and was there until the death of Herod, that it might be fulfilled which was spoken of the Lord by the prophet, saying, Out of Egypt have I called my son. Then Herod, when he saw that he was mocked of the wise men, was exceeding wroth, and sent forth and slew all the children that were in Bethlehem, and in all the coasts thereof, from 2 years old and under, according to the time which he had diligently inquired of the wise men. Then was fulfilled that which was spoken by Jeremy the prophet, saying, In Ramah was there a voice heard, lamentation and weeping and great mourning, Rachel weeping for her children, and would not be comforted because they are not. But when Herod was dead, behold, an angel of the Lord appeared in a dream to Joseph in Egypt, saying, Arise, and take the young child and his mother, and go into the land of Israel, for they are dead which sought the young child's life. And he arose and took the young child and his mother, and came into the land of Israel. But when he heard that Archelaus did reign in Judea in the room of his father Herod, he was afraid to go thither. Notwithstanding, being warned of God in a dream, he turned aside into the parts of Galilee. And he came and dwelt in a city called Nazareth, that it might be fulfilled which was spoken by the prophets, He shall be called a Nazarene. Matthew chapter 2. So if we have faith like Joseph had and Mary had and the others had, we can be guided by God too, and we can be guided by Jesus. We will have dreams and visions. We will have communication. And all we have to do is knock and open the door. Open the door. Knock and open the door and ask. And they're right there. They're right there waiting for us. But we have to open the door and ask. So I love you all. I hope you have a good week, and I'm praying for everybody. If you haven't given your life to Jesus Christ, I recommend it before it's too late. Until next time, God bless you. Go in peace, and I will talk to you soon. Good night.